Okay. Morning, guys. Welcome to our last synchronous session for this quarter. Can you guys see my screen?
Yes.
Okay. Okay. All right. Sige. Okay. Just a few reminders. So for those who haven't responded to the form yet, uh, which I put in the chat, please submit your responses for the exams. Currently, the leading availability of everyone is on um, April 7th, which is the last day of the final suite. Okay, so I just want to get a clearer picture of everyone's availability. So that's why I want you to answer the form as well. Sige. Aside from that, the submission for the lab 2, um, so it's been moved from March, uh, from today to March 31st. But then when I moved that, wala pa yung memo ni LS na no deadlines during Holy Week. So I will move it again to April 5th. Okay, so you'll have, I guess you'll have more time to look into your submissions. Okay, so hindi na today, it will be hindi rin March 31st, which is what's currently stated on Moodle. It's now on April 5th. Okay, I hope that's okay with everyone. Yun lang yung few reminders. By the way, regarding the finals exam, okay, so it will be asynchronous. It's also comprehensive. So everything that we discussed from week 1 up to this session will be included in the exam. Okay. So hindi naman as long as you understand the sessions or the basic concepts behind each sessions, and try to apply that, let's say, on a specific scenario, you'll be good on the exams. Okay, the exams would be part objective, so mostly in definitions, um, uh, trying to look into actual scenarios, um, uh, and see kung anong tawag sa scenario na yun. We'll also have one item for some sort of a case study ish kasi hindi naman siya full case study, no. So yeah, so basically it's an exercise, it's a dimensional modeling exercise lang, so that to check if you understand the 4 steps on doing dimensional modeling. Okay, so yun yung parts of the test. And the exams, it will be available for the entire day of the chosen day. Um, that's from anong oras based na isang class? I forgot. I think it was 6 a.m. to 9 p.m. I will open the everyone can take the exam anytime within the day. But once you start the exam, you will only have 2 hours to answer the test. Now, I suggest don't um, push it to 9 o'clock kasi I don't know how the exams are behaving in Canvas. In Moodle, if you click it on, let's say, 8:59, you will be able to take the test and take the full 2 hours. Okay? So mag-extend, open lang yung, as long as hindi mo close yung exam, you can take the 2-hour test. Okay? But in Canvas, I'm not sure, but I will just leave it open until 9 o'clock. Um, to be safe, please take your exams latest 7 p.m. if in case you want to take it at night. Okay. But yeah, it will be open from 6 a.m. to 9 p.m. Once you start the test, that's when the timer starts for the 2-hour test. Okay. My bonus items ba? Secret. You'll never know. But let's see. Yan natin. Okay. Any questions so far on the exams and the projects?
None so far, sir.
Okay, all clear. Sige. If no questions for now, I would like to proceed directly on the lecture kasi there's a lot of content. But you're still free to communicate with me through Canvas or through email. Okay? All right. Wala na ba ibang classmates nyo? Okay. Anyway, just admit them in case they come in later on. Okay, so for this session, okay, we'll focus more on the use cases of data science in business. Okay, so if you've seen the two videos that I uploaded for in Canvas, so those are more introductory for this session. Those are the two phases increased DM cycle next to business and data understanding. So once you get the full context of your problem from the business standpoint and from your data standpoint, you are now quote unquote ready to build uh, your whatever model. Is it analytical model like the dashboards that you're working on, or is it predictive model, which where you will do some sort of data mining, data science techniques, right? But today I would like to focus on these um, items. Okay. First, we'll look into clustering versus classification. That's a pretty common technique. We will look into some common algorithms under that and uh, see how they are being used. Okay, so pros and cons. Ganun. Next is that I would like to insert here specific for this class is association rule and sequential pattern mining. So these two actually have direct business uh, benefits or outputs. Okay, so we'll check that out later. And from the previous class, wala kaming time to take regression analysis, so I doubt that we will have time as well to discuss it here. But I put it there as optional naman kasi. So I don't think we'll cover regression analysis given our 1 hour session. All right. The goal of this session is for you to become aware of these different techniques, and so that when you see a business question, let's say I need to understand my customer segments, how they differ from each other, or I want to understand how should we place each products in the store. Okay, you would know right away what technique to do. Okay, we're not going into detail as to how to implement it, but at least have an idea on, ano bang approach ang kailangan natin gawin given a specific business scenario. Okay? So I hope you get that, you'll have that level of high level mastery from this session, right? So without further ado, I've spent 10 minutes of my time discussing the overview. So let's proceed with the clustering techniques. Okay. So from a clustering, the idea of course, this type of activity is to understand natural groups or clusters. Okay. It is to identify the average characteristics of available measures in groups. Okay. So for example, ano yung description nitong group na dark blue versus group na orange versus group yellow versus group light blue. Okay. Now, when running clustering algorithms, we are looking into high intra-cluster similarity, meaning all the items or data points within the same clusters are very similar, okay, or there's a commonality between those items, and low inter-cluster similarity, meaning once the groups are formed, we have to ensure that these groups are distinct with each other. Okay, so if they somehow collide or coincide at some point, then um, uh, clustering can still happen, but we cannot assure that it will be a good cluster or not. Okay, so there are three common algorithms that I would like to discuss in terms of clustering, which is k-means or median, agglomerative hierarchical clustering, and affinity propagation. Okay. All right. So for k-means clustering, I'm not sure if you've encountered this one. This is one of the common clustering techniques. So basically, coming from an ano ba, a k arbitrary points, we will identify ngayon kung ano yung magiging cluster. So for example, if we assign k equals 3, then we are trying to form 3 clusters. Okay, so we start with arbitrary points. So you can see we have the red, the green, and the blue. Okay, and then we assign each of the data points, the square data points, into the nearest centers. Okay, so this one is being assigned to this center. These items were assigned to this center. These data points were assigned to this blue center. That's the assign phase. Now, the update phase happens by looking at the average of all of the points assigned to that group. So since ito naman sa una, okay, since we're just looking at this point, so wala naman siya ibang i-average. So the center, that point became the center of the red group. Okay? Ngayon, itong green nag-move here as the center of the current green cluster. The blue move here as the center of, or the average center of the blue data points. Now, it will iterate again on step 2, which is the assign phase. So again, i-assign based on that new center, it will assign the data points again. So nakita natin, nag-move yung 2 items from green to red. Ito ngayon yung green data points, and these are the blue data points. Okay? Until it converges, meaning from time step I to I plus 1, hindi na nagbago yung members of each cluster. We can say that that clustering has stabilized or has converged already. And we can define that those are your final clusters. Okay, so this entire process is called the Lloyd's algorithm. It's the iteration between assigning and updating. Okay, just to simplify things. You can look at this animation. Okay, we have 4 animations now, 1, 2, 3, 4. You can look at each of them one by one. Bahala na kayo which one you want to look at. So as you can see, there's an initial assignment to the groups. It gets updated. The center gets updated, and then assignment, and then the center gets updated again. Okay, so let's try to watch it again for clarity. Uulit ba siya? Parang hindi. Ayan. So we start with 4 random points in the data set. Nag-assign siya ngayon ng mga data points near to those centers. Okay, same with this one, nag-assign siya. Nag-update ngayon sa center into the average of those cluster until it converges into their own independent clusters. Now, what can you see here? We actually have the same data points for these 4 scenarios, but we started on 4 different arbitrary points. Okay, so as you can see, after the convergence, we came up with different clustering technically. So ito, nag-ibang clusters niya compared dito. These two, luckily they end up with the same clusters, but you can see, but still the point is, the k-means itself is very reliant on its initial or arbitrary k points. Okay, so that's the one thing you need to understand about the k-means. At the same time, since we're using the average of data points, so any data point that is being added into the data set, whether it's an outlier or it's very close to the group, it will affect the new center or the average center, because averaging or means is very sensitive onto these different data points. So what others do is they rely on k medians, because they say that medians is more stable, less sensitive to move rather than mean or average. So for them, instead of averaging them, they look at the median of the data points, and then they use that as the updated center. Okay, but so those are the 2 variations for k clustering. One is k means, looking at the average of the data points and using that as the new center, or k medians, which is a more stable version of k means. Okay, but still the same process happens: assigning, updating, until it converges. All right, now that's k means for you. The next one is the agglomerative hierarchical clustering. As the name says, we are trying to make a hierarchy of clusters, okay? Hierarchy or binary tree of clusters. Now, initially, each data points, they are all independent clusters by themselves. Okay, they are considered as its own cluster. So say point 1, cluster 1, point 2, cluster 2, point 3, cluster 3, and so on. Okay, now they merge depending on a specific dissimilarity measure in a greedy manner. So let's say we will run through this from top to bottom. 1, 2, 3, 4, 4, 5 magkalapit. So we combine them. 6, 7 magkalapit. So we combine them. 8, 9, 10, and so on and so forth. Okay, so hindi niya hahanapin na, mukhang magkalapit si P1 and P5. No, it will not look that way. It will go through a specific flow, and kung ano yung makita niya agad na similar or highly likely to be part of the cluster, it will merge the two right away. Okay, and it's also a bottom-up approach. Although sa visualization natin, it's a left to right, no? But bottom up, we are starting from the data points themselves until we build all the clusters one by one and come up with one big cluster. Okay, so how do we read this output? Okay, so this output is called the dendrogram. Okay, don't forget about that. It's called the dendrogram. And let's say I want to have 3 clusters. Okay, so from this hierarchy of clusters, will simply cut the tree to come up with 3 clusters. So now I have one cluster composed of points 1, 2, 3, 4, 5, 6, 7, 8, 7, 8. Okay, another cluster which is 0.9, 10, 11, 12, 13, and another cluster which is 0.14. Okay, now what if I want to have 5 clusters? So now we will look at a level where when we divide the tree, we will come up with 5 different clusters. So it is at this level. Okay, we have this cluster, this cluster, this cluster, this, and the last cluster. Okay, as you can see, it's uh all the efforts technically, or the computing efforts, happen at the start or building the dendrogram. Okay, but after that, we can easily come up with any number of clusters that we could. Of course, the maximum number of clusters will be the number of data points that you have. Okay, visualization is also easy to look at, and you can simply divide the tree depending on your number of k. So compared to k means, we don't need to define the number of target clusters. We don't need to define the value of k. Okay, that this one provides us already with all the possible clusters that we can have given our data points. Okay. Now this is a high level process of doing agglomerative hierarchical clustering. So first we measure the distance between each data points. Okay. Next is we merge the nearest clusters, and then we update the distance matrix. Okay. How does it look like? So for measuring, we have each of the data points here, the A, B, C, D, E, and so on. And we have each data points as well at this side. Okay, this is just my way of representing things. So of course, when this is implemented, there could be different things happening behind that function. Okay, so here we look at the distance. So of course, A to A, they are the same point, so the distance is 0. A to B is 18, A to C is 28, and so on. Okay, and from here, from all of these distances, the nearest ones are B and H, which is at 1.73. Okay, so now we combine the two, we will now have a BH cluster. Okay, so magiging BH siya, and mawawala ngayon si H. All right, and then the update happens when we again recalculate the distances now from A, instead of to B, from A to cluster BH, A to C, A to D, BH to C, BH to D, BH to E. Okay? So ngayon, we have 2 points in one cluster. How do we determine kung anong point yung i-measure natin for the distance? Okay? Which ones are we considering when we are computing the distance between A to either B or H. Okay, so that is answered by the linkage criteria. Okay, so we have 5 different criteria here. Okay, single linkage, complete linkage, average group, centered distance, or Ward's method. Okay, so let's pretend we have 3 data points, which is A, this is B, okay, and para madaling ma-recall, we have the H here. Okay, initially we know that B and H are already one cluster. Diba? Okay, so yan, one cluster na siya. So when A comes in and let's say we identify that A is the next nearer data point to these clusters, how do we define whether to measure the distance from A to B or A to H, since both belongs to the same cluster? Okay, that is where linkage criteria will come in. So when we talk about single linkage, that means that we will consider the minimum distance between the two. So we will compute the distance between A to B and A to H and see which one is the minimum. Okay, so let's say kung minimum siya, kung single linkage tayo, magkoconnect siya kunwari kay B. So that's how it will compute the distance. If we go for complete linkage, which is the maximum, and let's say the maximum between the two is AH, then it will attach itself to AH. Okay. Now, another interesting here uh, is the average group. So what happens is we compute the average of B and H. Let's say the average is at the middle, this one. Then A will calculate its distance with this average. So ito yung ika-calculate niya na distance instead of kay B or kay H. Okay? And then it updates the distance matrix, and then the same thing happens. We look at the distance, we merge near clusters, and then we update the distance matrix. Okay? Now let's look at an animation. Okay? So ulit tayo. We have here P6 and P5. It combined to C1. As you can see, it's moving into the center of the 2 points. So we can conclude that this animation is working at the average group linkage criteria. Okay, so P6 to P5, naggitna siya. P4 to C1, it becomes C2. P2 to P1 becomes C3. P3 and C2 and P0. Okay, na-lost na ako, pero you can follow the animation. And this is the corresponding dendrogram for that. Okay, so at this point, we now have 3 clusters. So ikakat natin siya, we have these 3, we have 2, until we have one big cluster where all the data points are in. Okay. I hope this visualization is kind of clear enough of what we're trying to do with the agglomerative hierarchical clustering. Okay, so the last one is affinity propagation. So again, instead, one of the weaknesses of the K clustering is that we need to define the clusters. And if you're the business user, I mean, if I want to understand, if I just want to explore, I have no idea kung ilang clusters yung gusto ko unless I really have a sturdy or really wide domain knowledge na alam ko agad the optimal clusters would be 5. Ganun. So I don't know that. And it also depends on the data itself. So there are a lot of techniques that was being used that tries to avoid that requirement. So one of them was agglomerative hierarchical clustering. Now this one is affinity propagation. So it's taking the similarity scores between 2 data points as input measures, and then it's simultaneously consider all data points as potential exemplars. Okay, so there are 2 parts of the algorithm. So one is to calculate the responsibilities, okay, which data points would belong to a specific center based on those similarities, and then calculating availabilities. Can that center still accommodate for more data points? Okay. The animation here is what is the representation of that algorithm. As you can see, it starts, each data point starts with very thin edges. And as the iterations happen, it becomes thicker and thicker until selected edges have become evident. Okay, those selected edges meaning those thicker edges meaning that these data points now belong to that specific cluster. Okay, so ngayon nag-end up siya with that three groupings coming from ilan ba to? X number of data points. Okay, this is usually used when you want to compare different behaviors of same people. Okay, so it's commonly used when you want to understand your customer behavior. Let's say, what's the difference? How will you group people? Okay, let's say you group people according to their age. Okay, a 1 month subscriber versus 2 month subscriber versus 3 month subscriber versus 4 month subscriber, and so on. You look into their transactions, and then from here you can see, you can compare, you can use affinity propagation to compare the behavior of each of those clusters. So we can say that, for example, we can say that cluster 1 and cluster 3 both purchases beers and diapers at the same time, while cluster 1 and 5 both uh, are purchase a lot of male hygiene products. Uh, so you can find those different behaviors. Okay, um, using affinity propagation. All right. So any questions with clustering?
None, sir.
None for
All
me,
right.
sir.
Okay. Sige. Now let's proceed with classification. Okay. So how is it different from clustering? As you can see earlier, we're not looking into um, we're not telling the algorithm to assign them into a specific item. Okay. More or less, the k-means we start with a very arbitrary one. Okay. But in the end, it's still more of natural associations rather than prediction. Okay. So that's a difference, main difference between clustering versus classification. In classification, we know already the labels that we want. Okay. We know, if we look at this picture, we know that what is a plant, we know what is a mammal, we know what insects are, we know what birds are. Okay, we know the definitions of these groupings. We simply assign each data point to each of these bins or groups. Okay, so that's why it's more of an assignment rather than segmentation. It's more of prediction rather than natural association. And for technical terms, that's why it's called supervised learning, okay, rather than unsupervised, because of the existence of these labels in performing classification. Okay, so for example, if we look at specific business cases, okay, credit scoring, okay, this is not referring to assigning you a score, but this refers to uh, the process behind that, or what happens before banks assign you a score. Okay, so for example, they will look at their um, list of customers given their banking or credit behavior. They will look at which ones are considered low risk, medium risk, and higher risk. Or let's say if they have a continuous scale, they will start putting you into they will start assigning you some figure from some a figure basically. Okay, but before assigning that, the company doesn't know. Okay, what does low risk mean, what does high risk mean? Okay, so wala silang idea of those labels, so they will just form three different clusters depending on specific behaviors and business rules. Okay, insurance risk, the same application. Customer segmentation, so if you want to look at your natural segmentation of your customers. And you can also use clustering to assume or filter missing data. Okay. Now, in classification, okay, yung counterpart niya on the classification side is when, let's say, you apply for insurance or credit loan, they will look into your profile and see whether you are a high risk, low risk, or medium risk. Okay, so ganun na ngayon siya. So now they are, based on your profile, they will assign you a score or a risk category. Okay, they can now offer you specific products kasi they know which segment you belong to. Okay, and last, you can also determine missing data given the clusters or the behavior of or the characteristics of commonly available rows. Okay, so let's say meron kayong missing data on one column. Okay, just identify kung ano yung um, clusters nyo on those complete rows, and based on those behavior, dun nyo ngayon i-assign yung mga missing rows na yun. Okay, so to identify, to have an idea of what the value of that missing field was. Okay, so now combined use of clustering classification provides real discovery power. It's not usually the case that it's clustering then classification. It can also be classification and then clustering. So it really depends on the business case. Just to give you an example, let's say you're doing classification already coming from clustering, okay? And you want to update your clusters because hindi naman for all the time you are a low risk bank customer. Maybe based on your recent behaviors, your behaviors have been considered high risk. Okay, so now if they update the clustering, they will have new definition. Okay, now you will be assigned to that category. Okay, so if the clustering definitions need to be updated, usually they go back to clustering techniques to recalibrate the clusters. Okay, now we've mentioned supervised learning. Okay, it's basically the existence of the target or dependent variables. Okay, not just the inputs. Okay, the inputs are considered predictors if you're coming from the statistics background, features if you're coming from pattern recognition, or what we've been discussing for quite some time, dimension. Okay, since we're talking about data mining. So all of these naming conventions are all considered independent variables and are inputs to supervised learning techniques. Okay, the outputs would be a response or a target, which is a dependent variable. Okay, and this is actually made known, okay, before the start of the modeling activity itself. Now, simple approaches to prediction, you can do classification, which what we will be discussing, and we will also have regression, which we cannot discuss, but you can. There's a lot of resources already regarding regression, and some of you might have encountered regression already in your other classes. Okay, let's move to this. Okay, now what is k nearest neighbors? Okay, basically we have a sample query here. Okay, in this case it's the star. Okay, based on the neighboring data points, and we will look at the majority of the labels, and then we assign that data point into that label. So for example, if we assign k equals 3, that means we will investigate 3 of its nearest neighbors and identify the majority and then assign that point to that class. Okay, so we look at k equals 3, the majority is class B, which is the purple one. So we will assign this data point, the star, to class B. Okay. Now, it's good if you have large training data. You have a lot of information to ingest technically. Okay, and you can somehow assure on the accuracy of the labeling. It's because it's dependent on historical data. Okay, because we're looking at large training data. So we can be across the time horizon. Okay, we can assure that it's true that data point, since it belongs to a majority of this specific label or class or score. Okay, then that's the score of that new data point. Okay, but as you can see, it's also very dependent on the number of k. So if we increase the number of k to 6 coming from 3, okay, now we look at the nearest 6 neighbors. We now have the majority shifted from class B to class A. So now, since we are looking at large horizon of data points, right? So the clustering could also change. Okay, so that's one weakness of the k nearest neighbor. It's very dependent on k, that let's say a large K would make the boundaries between each class less distinct, but a very small K, okay, would be very dependent on the noise. Okay, so as you can see here, we have some blue points randomly placed on the orange um, data sets, okay, orange labels. So if this area tend to be noisier as this looks like, okay, then it will be consuming a lot of resources, okay, computing resources in this case. But whereas if we look at k equals 15, okay, yes, we can clearly see the difference between the orange and the blue clusters, but we can see that there are some points on the orange side and the blue side which are mislabeled. Okay, so we have these orange points on the blue clusters, we have these blue points on the orange clusters. Okay, so you still need to strike a balance between the level of your K. So the robustness depends on the value of K and the distance formula used, because we don't just have Euclidean distance formula. You can use different distance formula, and that could even affect the robustness of your clusters. And accuracy can be highly degraded with the presence of noise or irrelevant features. Now, to attack this one, so we have newer classification techniques, which are the DB scan, which looks really at the density of nearly like data points, okay, before they can come up with such classification, right? Now, the second one is decision tree. So as you look by itself, it's a very intuitive approach in classification. Sorry about that. Let's say you want to play golf. You have these two decision branches or logical branching of rules. Is it windy? Yes. Now let's look at the outlook. If it's rainy, then don't play. If the outlook is sunny or overcast, then let's check the humidity. If it's low, then we play. If it's high, we don't play. Very easy. So it's a derivation of rules. Okay. But if we look at the data set, it looks like this one. So we have each scenarios. Then we have these different columns. Okay. So the outlook, temperature, humidity, windy, and the label or the class. Okay. Oops. All right. So this is the class of each of these line item. Okay. This is the equivalent model of this one. Okay. So we now have these different types of this kind of decision tree. Okay. So what happens here is that coming from the training set, okay, this has been discussed on the previous videos. You need to come up with training set where you will actually learn, which is actually considered the training or the learning phase. Okay, we will use a tree induction algorithm, which will output a decision tree model. Okay, and then from here we will apply the model to our test set to see the accuracy of this decision tree. Okay, so now we can start assigning new items, okay, into this decision tree. Now, the advantages of it, of course, the tree output, as you've seen earlier, it's very visual, easy to understand, extremely fast at classifying unknown records, because for most decision tree, for most applications that create decision trees, if there are any missing fields, they will group them together into a missing category. So let's say dito si Windy, may kunyari wala tong si no, wala tong si yes. Automatically one item here on the Windy part, okay, wala siya sa model. One item in the Windy part would be missing or unclassified, and they are treated as another rule or another bin. Okay, so it's very easy to understand or to classify unknown records. Easy to interpret as well if you have small sized trees like this one. Okay, automatically you can see kung ano yung flow of the decisions. And then it doesn't require domain knowledge, and it's useful for all data types. But again, there are some weaknesses to decision trees. It's very sensitive to the first split. Okay. In this case, I did not dictate the tool to start with the um, uh, play, no, with the outlook column. Okay. So if they start with temperature, if they start with humidity, with windy, this tree model will change as well. So it's very sensitive to the first split. In this case, it's the outlook. Okay. It examines a single field at a time. So it goes through of each data columns one by one, and it's also prone to overfitting. So because it's very reliant on the test set or the training set, then there's the tendency that other or new data points or new scenarios will not fit into that decision tree. All right. Any questions between classification versus clustering?
None, sir.
None for me, sir.
Yeah. Okay. Let's proceed now to association rule mining. Okay, we'll probably be extending the session again. Okay, let's proceed. Let's just give you a quick story and starting association rule mining. So there was a story or the parable of the beers and diapers. Okay, so they were one big retailer tried to look at the patterns of purchases, and they identified that beers and diapers usually go together in the receipts. So now they start asking, why does this happen? One product was associated with infants, while the other was associated with adults. Okay. Now they look into the demographics, and they found that this pairing usually happens during Friday afternoons and is usually being bought by young, in this case, American males. Okay. So now they actually concluded that these are actually the new fathers who are stocking up diapers and beers for the weekend when these people are usually at home. Okay, so um, they see that it drives the purchase of both diapers and beers every Friday. Now, another story is about the Target. It's been a buzz on both retail industry and um, analytics industries. Okay, because using association rule mining, they were able to identify which products are associated with pregnant women or pregnant families. Okay, because the behavior of people wouldn't change really. Okay, most people are habit creatures, unless something really significant happens. So one case is pregnancy, and the behavior of the purchasing will also change because of pregnancy. Now they look into it. They found out some items. Let's say first 20 weeks, the supplements like calcium, magnesium, and zinc are highly bought. Beginning of second trimester, large quantities of unscented lotion were bought. Before delivery, lots of scent-free soap, extra bags of cotton, hand sanitizers, and washcloths. Okay. Now from this, they started distributing coupons as a part of their marketing campaign to potential pregnant women. Okay, so now one father kept on receiving these coupons, and he was asking, "No one's pregnant in this house. Why are you sending us coupons about these products?" Technically, and then he was so ready to sue Target, but in the end, uh, he didn't know that his daughter was actually pregnant. Okay, so Target was ahead to know that than the father itself, the father of the girl, that the girl is pregnant. Okay, so it's a buzz because it can see here what the power that analytics can provide each company, but at the same time, it's also a borderline ethical concern. Okay, where do you draw the line of making up these insights or campaigns? And in this case, you technically quote unquote disclosed the pregnancy of a customer to people who don't know who don't know their status technically. Okay, so it's a borderline ethical issue as well. Okay, enough of the story. Let's proceed. They are looking at the association of different products. Okay, so they are discovering interesting relationships or associations hidden in large data sets. They attempt to find associations between entities based on the transactions involving them. Okay, so by searching combinations of items whose statistics are quote unquote interesting. Okay, it's also called the market basket analysis because, again, driving from that concept, we are looking at each basket in the grocery technically. Okay, it's a simplified model. Okay, you might have 2 3 baskets, but let's consider one basket per customer. We look into each different basket and see what are the pairings, what are the common pairings of items or item sets. Okay, so why do businesses do this? First, they want, of course, to increase revenue from cross-selling and affinity positioning. Okay, let's say one young American male came into the cashier handling or having diapers. The cashier could simply say, "Oh, sir, would you like to have some beer with that?" um he might agree right away. Oh yeah, I need beer for the weekend. It's true. So that's increasing revenue. At the same time, we can position the beers and diapers all together in the grocery during Fridays, so that when fathers come in, oh, both of the items that I need are actually placed together, so I don't have to walk all throughout the store. So that's a good thing. Okay, that's also additional consumer experience for that father. Okay, and at the same time, we increase the revenue. Also, we were able to sell more products to him. Okay, so also it's increasing customer loyalty, and from an inventory perspective, we can reduce shipping cost by actually stocking usually bought pairs of items together. Okay, so if we know that beers and diapers will happen, let's purchase them all together so that we can put them into one shipping cost and maybe leverage on some discounting because we're looking at moving huge amounts of products. The data mining task is called association rule mining. Again, the goal is to identify what products tend to be purchased together or consequently. So what drives the purchase of another product. Okay, but there are 2 key issues here. It can be computationally expensive, and some patterns might just happen by chance. Okay, so they might not be the actual trend at that moment. All right. So from the data set, this is a simplified version of the data behind it. So we look at each transaction ID and we identify whether specific items exist on that basket. So let's say if there's bread, it's true, it's 1, milk 1, diapers 0, 0, 0, 0. This is binary representation, so we are simply looking at the existence of these items per transaction. Okay, um uh we don't classify whether there's 2 pieces of bread, there's 5 boxes of milk. No, we're not considering that. As long as there's bread and milk, we tick 1 on each of these cells. Okay, so this is the simplest view of real market basket data. Okay, but other aspects can be considered to increase the insights that you can get: quantity of items sold, unit price, cost of goods sold, or even the sequence of purchasing. Okay, so let's say we have this basket, we have the transaction ID or the basket ID, and this basket contains bread, milk, diapers, beer, eggs, and cola. Okay, so this is what we call a transaction. Okay, and specific items under it is what we call the item sets. So we have the item set for bread and milk and eggs, diapers and beer, and item set for bread, milk, and cola. Okay, so these subsequences, okay, or baskets, sub-transactions, if you want to call it that way. These are what we call the item sets. And support count refers to the number of transactions that contain a particular item set. So you can find maybe 5 out of 10 transactions containing bread and milk. So the support count for bread and milk will be 10. Will be 5 out of 10, right? So these two also contain these are 2 different item sets, but one contains the other, so that's also considered as a separate item set. Now, in association rules, okay, when you run this through applications, let's say RapidMiner or any analytics tools, you will actually get these format. Okay, these are what we call the association rules. Okay, we have an antecedent, okay, and we also have the consequent. Okay, we also have uh, two figures usually here at the side, which is a support, how often a rule is applicable to a given data set, and confidence, which determines how frequently items in B appear in transactions that contain A. Okay. If we put it in a formula, okay, the number of um, uh, transactions that has A and B over the total transactions N. Okay, for coverage, it's a number of transactions with A and B divided by the number of transactions with A. Okay, so it's like okay, like I'll explain later on. So the coverage will be the number of transactions containing A. Right. So why do we use support and confidence? So these are the interesting statistics that you want to look at. Support is being used to eliminate uninteresting rules. So if the support is very low, which means that it can mean that it only happened by chance. Okay, so it's not interesting from a business perspective. But for confidence, it measures the reliability of the rule, how true or how confident are we that this rule actually is a true rule. Okay, so the higher the confidence it is, the more likely it is for B to appear in transactions that contain A. Okay, it also provides the estimate of conditional probability that B is in the set of transactions given that these transactions have A in it. Okay, but word of caution, causality may be evident but not always the case. So you can um, compare this, with correlation doesn't mean causation. Okay, so association rules only measure the relative occurrence of the values. If you want to derive causation, you need to come up with further experiment, which I'll show later on. Okay. Eliminating. Okay, let's skip this one. This is more technical discussion already. So if we look at rapid minor, this is the process. So we get the data set, we convert it from numerical to binomial, which is the binary representation. We then run it on an algorithm that creates the rules, so which creates the frequent item sets first, and then we from the frequent item sets we come up with the rules. Okay, so what does frequent item sets mean? Okay, so in this case, we can have, let's say, 5 different items A, B, C, D, E. You can have item sets A, B, A, C, A, D, A, E. You can see earlier, no, parang one item set containing others. From this, we can build item set A, B, C, A, B, D, A, B, E, and then A, B, C, D, and then you can come up with a bigger item set, which is A, B, C, D, E. Okay. There are ways. If we look at this one, if we come up with the entire structure for all the products, then it will take so much computing resources. It might take so much time to technically solve our problem. Okay, so we need to reduce the candidate item sets, which is the a priori algorithm, and we want to reduce the number of comparisons happening, which is the FP growth algorithm. So both addresses two different issues. Okay, so what is the a priori principle? It simply means that if an item set is frequent, then all of its subsets must be also frequent. So in this case, if CDE is frequent, then we can consider that item set CD, CE, DE, and CDE, and even the zero item set are all frequent. Conversely, if an item set is infrequent, all the item sets containing it will be infrequent as well. So if AB is considered infrequent, ABC, ABD, ABCD, ABCDE, and so on are all infrequent. So we can simply cut or prune this structure, removing these infrequent item sets, and just consider the rules on the rest of the item sets. Okay. So now there are terms to describe association rules. We have the coverage, support, which we discussed earlier, confidence, lift, and leverage. We discussed the first three pala earlier. So coverage is how many baskets contain item set A. Support is how many baskets have both item sets A and B in the same A and B. Confidence, how many baskets have have A's, how many baskets with A's have B's? Okay, so okay ba yun? And then we have the lift and leverage. So here, if we put it on a mathematical formula, we can put it, I'm just putting it as a probability kasi ano naman siya, A over N naman, no? The number of transactions with A divided by the total number of transactions. We have the probability of, we have the items containing A and B. Then the confidence is a conditional probability. So probability of B given that item set A happens. Okay, so the item sets that have B given that these item sets, these baskets have A. Okay. They also have a formula for support, lift and leverage, and I'll explain this formula or the interpretation later on. But to explain this further, let's proceed with a simple exercise. Let's say we have 8 transactions among 3 items, and we want to look at rule AB. Okay, so if we look at the formula again, okay, we have the coverage. We have 5 baskets containing A. So 1, 2, 3, 4, 5. For support, how many items have both A and B? So there's actually 3. So 1, 2, and 3. Okay, so 3 out of 8. So 0.375. Confidence is the number of uh, transactions containing B given A. Okay, so we can simply divide the support by the coverage. So 0.375 over 0.625, which is 0.6. That's the confidence of the rule AB. And then we follow the calculation for lift and leverage, and we come up with 0.96 for lift and leverage for negative 0.015, right? So now, how do we interpret the lift and leverage? So lift and leverage describe the relationship between the antecedent and the consequent. So given these values, we can identify whether the item sets A and B are complementary, are they independent, or are they competing each other? So now my question is, given these values, okay, that the lift is 0.96 and leverage is negative 0.015. I type it in chat. What do you think is the relationship between the two item sets, between A and B? Are they complementary? Are they competing? Or are they independent?
They're competing.
Competing. Okay, that's correct. So they are actually considered competing. So from there, you can derive already na items that's A and B, in this case, it's apple and banana, they're actually competing products. Okay. We can also identify further insights which products are complementing each other. So you can actually place them all together. Or in this case, would you like to place apples and products at the same time? Probably not. Probably yes. It depends on your on your approach on competing products. Okay. We're actually 12. It's actually 12:02, and there's one last video that I want to show you. So it's if you are free to extend for 10 more minutes, that would be great. Okay, but the session is recorded for those who cannot join the class. So is it okay with everyone? So I'll just play this video for sequential pattern mining.
Yes, sir.
All right, sige. Kainin ko muna yung onting lunchtime niya. I'm sorry about that. But the sequential pattern mining, how it differs from the association rule mining. So in association rule mining, we look at each basket or transaction and see ano yung common pairings. But we cannot really identify kung the apples and bananas purchase will happen in the future. Okay, so we want to take these baskets into a time scale so that we can actually see it on a time. We can foresee whether these items will be happening in the future or not. Okay, so we're now considering the time horizon in this case. Okay, so let me just play the video. Can you hear the sound?
Yes, sir.
Okay.
First, we are going to discuss sequential pattern and sequential pattern mining, the concept. So the first thing is we should say sequential pattern mining is very useful, has very broad applications. One application could be in customer shopping sequences. For example, you get loyalty cards for your shops. You may want to see maybe one customer likely going to first buy a laptop, then a digital camera, then smartphone within 6 months. If this forms a pattern, you may be able to try to do some kind of advertisement to other similar customers, or serving some new incentive for this customer. Like a medical treatment from sequences, natural disaster like earthquake happening, it may have some sequences of natural and also human phenomena. Science engineering, a lot of things are processes. They evolve along with time. Similarly, stocks, markets, they have some kind of duration sequences. Weblog click streams, calling patterns for telephone and other things forming sequences. Even for software engineering, the programming execution form sequential patterns. The biological sequence is very, very useful for analysis, like DNA sequences, protein sequences. So we'll see trying to get sequential patterns out of those very big, vast applications could be very useful and important. Actually, we can distinguish transaction databases. Usually may not be important to look at their time effect. Sequence databases, they have timestamp attached with it. Time series databases, usually the time things happened actually is along the even or equivalent time intervals. Sometimes it's very consecutive. Then for sequential patterns, actually there are two kinds. One is gapped, another is non-gapped. The gapped pattern means you do allow to have gaps within those patterns. The non-gapped patterns means you will not allow these patterns. The sequence, everything is important. The consecutivity is important. If you have gap, you have to treat them very seriously. For example, for shopping transactions, probably you don't care customer in the middle buying some other things, so it's not important to study the gaps. Clickstream, sometimes you may say, some clickstream you may care about gaps, some you probably do not care about gaps that much. For biological sequences, in many cases you do care gaps. So the protein sequence or DNA sequences, if you insert many things in the middle of the two DNA sets, sometimes you may completely change the function. So let's look at the customer shopping sequence as a major example to study how to do sequential pattern mining. Sequential pattern mining essentially is you give me a set of sequences. The algorithm is trying to find the complete set of frequent subsequences satisfying certain minimum support threshold. Let's look at this example. We have a sequence database containing like 4 customer shopping sequences. Okay, what's the meaning of this? We look at this particular sequence. This sequence, the parenthesis means this one is within the same shopping basket. Then after that, you get another one, AB, that means this AB, following EF. But AB is getting together at the same time. Similarly, DF getting together but following AB, and then C, then B. Okay, that means each one of these you can think is an element. It may contain a set of items, or you call events. Then this one event may follow another one. The items within the event, the order is not important because they are in the same shopping basket. But for our convenience, we can sort them alphabetically. Then what is subsequence? Actually, any substrings within this one, you probably can see here, the subsequence, you may have a gap. For example, you say you can have A, you have BC. BC, actually, you chop this A. You can chop complete AC, then you get D. You can chop one F, you can get C. So this one is a subsequence of this longer sequence. Then sequential pattern mining. The sequential pattern essentially is, if you set a support, like a minimum support is 2, that means at least the 2 sequences contain the subsequence. You find those subsequence, this is a sequential pattern. For example, A, B getting together, then C. In this sequence database, this is a pattern of support 2. So sequential pattern mining algorithm is you try to develop algorithms which are efficient, scalable, and these algorithms should find a complete set of frequent subsequences, we call sequential patterns, and also should be able to incorporate various kinds of user-defined constraints. For sequential pattern mining, actually, Apiary property, the property we have used in frequent pattern mining, still holds. For example, if we say a subsequence f sub 1 is infrequent, then any of its supersequence cannot be frequent. So that's almost the same idea as Apiary. So based on this idea, we actually can develop lots of algorithms. One represents.
Okay, I'll just stop there because he will describe more of the new algorithms for sequential pattern mining. So as you can see earlier in association rule mining, or he mentions frequent set mining. Okay, we look into individual transactions and see which are the common pairings. But in this case, you can imagine, what if in a queue of customers, how often will we see apples and bananas on those different customers? Okay, so we will now consider multiple baskets in one queue or in one time scale. So in one sequence in this case. So it's also needed. It's also an interesting pattern to look at besides association mining. All right. Any questions so far? I know we are ahead, over time by 10 minutes, but thank you so much for coming in. But that's actually the end of the lesson. We're not covering regression analysis anymore. Are there any questions?
None naman po, sir.
Sige. Or baka wala pa yung question now, but you're free to reach out as well. Now, one more thing, maybe because it will also upload this document. Together with this video. Okay, so we have this presentation by Dr. Reina Reyes. She was used to be with Ateneo or even with DISCS, teaching data visualization, but now she is with the National Institute of Physics in UP Diliman. Okay, if you're not familiar with Reina Reyes, she was the one who was able to prove Einstein's theories. Okay, at the current using their research today. Okay, so what she did is she looked at senatorial elections data set, and she used market basket analysis and affinity positioning in order to identify who were voted together and which provinces voted similarly. So I will upload this also in Canvas together with the recording, and this will be the last discussion thread or the quiz na lang, last quiz for this week. Okay, so with that, that commences the week. That commences, hindi pa naman nagko-commence yung quarter, but in terms of the outline, that's where we will end. I hope you got something out of this class, out of this quarter, kahit paano. And thank you for bearing with all the challenges we had, all the chaos that we had during this quarter. But I appreciate everyone staying in until this last point. All right. If wala nang questions, I'll end the recording.